First of all, I have drawing on the board back again, which makes me happy. I don't know about you. I'm happy. Where were we? We had guessed that was our guess. Remember, we're trying to solve the two-period overlapping contract model. One thing I have to say to you before we start, so I don't forget. Just before class, I uploaded some old exam questions. There's not lots and lots of them, but there's some, so you can get an idea what exam questions look like. Some written exam questions and some MCQ questions. Of course, the midterm next week is going to be MCQ questions, so that's the most relevant at the moment. But the other ones tell you what sort of things you're supposed to get out of these models, and that's helpful because there could be questions about that as well. So those are up just now, and take a look. Of course, exam is next Thursday, and there's no class on next Friday. Okay, so we're trying to solve this model, and we made this guess, and given that this guess is true, we saw what the true process looked like. And the true process looked like, if I have notes, yes, it looked like PT equals 1 minus R1 theta ET plus rho minus gamma minus theta over 2 R2 plus rho squared ET minus 2. Right. So we made that guess. We had the true process, which involved these expectations. We made the guess. And we put everything in the guess that people knew at time t minus 2 and everything that they might have learned since then. So they knew at t minus 2, they knew vt minus 2. And then these shocks were things that they might have learned since then. Another way to think about it is that everything that was in the real process, we put into our guess, right? And we put it into in a nice linear way because we're not gluttons for punishment and we don't want to be masochistic about this thing. So let's start with linear, see if that's right. And in this class, it always will be. In general, it is not necessarily always correct, but in this class, it'll always be correct, linear. And we made that guess, and then given that the guess was correct, which we don't know yet, but if the guess is correct, then we could find out what these expectation terms are. And we could use this guess to find those expectation terms, to find the price prediction errors, and we could take that and plug it into the actual process. And that got us this second equation here. And now we're wondering, was that guess correct? And for that guess to be correct, that resulting thing has to be the same as our guess, right? Because that's taking into account both our guess and the real process. Could we close the back door there? It's a bit loud out there. Someone could grab the door. Thank you so much. So that's the idea. So we're wondering, does this look like our guess? Are these two consistent? Well, at first glance, yeah, it's looking pretty good, right? It's looking good because we've got, well, in our guess, we have something times ET, something times ET minus 1, and something times VT minus 2. And in the resulting process that we got, when we combine that with the real world, our star equation, we have something times ET plus some unpleasant thing, and this is supposed to have an ET minus 1 next to it. Like so. Something times ET minus 1 plus something times VT minus 2. So it's very encouraging. It seems like maybe our guess is correct. But we do have to see whether there is any somethings that are consistent with each other. Right? It's possible to get this sort of thing and have them still not be consistent with each other, so we need to check that they are. We need to find out what R1, R2, and R3 actually are. Okay. Well, R3 is easy, right? R3 is easy because we just say, well, there's R3 in the guess, and there's this something multiplied by Vt minus 1 here. If our guess is correct, those two have to be the same. If they were different, then our guess would be wrong. So it must be the case that R3 is equal to rho squared. I remember rho was how slowly the shocks died out, right? And this is saying the prices depend on rho squared times Vt minus 2. And that's rho squared is how much of that shock is going to be left, right? If we had a shock if we had the velocity in period 2, 2 periods later, 1 period later, rho of that would be left, and 2 periods later, rho squared of that would be left. So that's not a shock that we get rho squared there. It's encouraging and nice and happy, right? Okay, now we need to find R1 and R2, and these are a bit messier, right? So if our guess is correct, R1 has got to be equal to this thing here, 1 minus R1 theta. Right? If those two are equal, then the guess can be correct. Well, can we find an R1 such that that is true? Well, I get, adding R1 times theta to both sides, I get R1 theta plus R1 is equal to 1. Factoring out the R1, I get 1 plus theta, R1 equals 1, and R1 is equal to 1 over 1 plus theta. Which is nice and lovely and happy, right? So if that is true, then our guess looks just like the resulting process. Okay? So the only leftover bit is R2 has to be equal to this unpleasant thing. So I'm going to go to the next page, and I'm just going to be saying R2 has to equal this. Rho minus gamma minus theta over 2 R2. Those two have to be the same. So I just need to solve this out, and I'm going to add theta over 2 R2 to each side. So I get theta over 2 R2 plus R2 is equal to rho minus gamma. Factoring that out, that's 1 plus theta over 2 R2 is equal to rho minus gamma, or R2 is equal to rho minus gamma over 1 plus theta over 2. Now we could write that differently if we wanted to. We could, having fractions in the denominator freaks me out. Like I get heebie-jeebies, like terrible things can happen to you. The end of the world, cats and dogs living together. You don't want to get involved in that. But in this case, it's kind of nice to see that theta over 2, right? Because remember, theta over 2 is the proportion of, the 1 over 2 is the proportion of people that have 2-period contracts, right? So this theta over 2 is really the effect of those people with 2-period contracts. But I could, if I wanted to, write it differently, right? I could have written this thing as 2 plus theta over 2. R2 is equal to rho minus gamma. And then when I did my division, I would get R2 is equal to 2 rho minus gamma over 2 plus theta. These things are, of course, exactly the same thing. Normally, I would try to get rid of all the fractions in the denominator because life is hard enough. But in this case, I kind of like them, so I'm going to keep them around. But, you do you. Either way, it's exactly the same thing. Okay, so what does this mean? It means our actual process. So we have verified this, right? we verified our guess. We said, if the guess is correct, here's what price prediction errors look like. Let's put those into the real process and see if that's consistent with the guess. Okay? And if we get R1 is equal to this thing, R2 is equal to that thing, R3 is equal to that thing, then they're all consistent with each other, and our guess is fine. Again, we don't know that this is the only equilibrium, but we know that this is an equilibrium, and it's going to be the one we go with. Right. So what do we have? We have PT is equal to, if I can remember all this stuff, R1 was what? R1 was 1 over 1 plus theta. It was 1 over 1 plus theta ET plus R2 is rho minus gamma over this thing. ET minus 1 plus rho squared ET minus 2. And that's our equilibrium price process. That's how prices work in this model. There's some bit of prices that are left over from 2 periods ago, right, the rho squared. There's something because of yesterday's shock. It has something to do with theta over 2 is this number of people that have 2-period contracts versus 1-period contracts. So something to do with them and something to do with gamma, which is our monetary policy, right? Where we're reacting to ET minus 1. And that's not shocking, right? Because we are changing our money supply based on the shock in period T minus 1. So if gamma is saying that if we're increasing our money supply, we're going to have higher prices. And if we're decreasing our money supply, we're going to have lower prices. Okay? And then it's going to depend on today's shock as well. Okay. That's what we got. But we're not really interested in prices so much, right? We're interested in output. Do I have that? Oh, of course, the notes don't have that. That would be too easy. Okay, so let me go back briefly. I don't have any of that. Oh, fun times. So if we go back into the mists of time, which is last time, we found a couple of things. We found what these price prediction errors look like, and I'm going to write them down on a piece of paper. Okay, so we have this one that we found as we were going along, that PT minus PT given T minus 2 is equal to R1 ET plus R2 ET minus 1. And we also found, this one I know by memory, but we have it here? No, we don't have it here. We have it here somewhere. PT minus PT given T minus 1 is just going to be equal to R1 ET. Right, so if we go forward, we're going to have PT minus PT given T minus 1 is equal to R1 ET. Why? Because the only reason you're going to make mistakes, if you're trying to predict prices 1 period ago, the only reason you're going to make mistakes is because of stuff you don't know. Right? On the left-hand side, we have the mistake that you're making in guessing the price. This is how the price works. So the only reason you're going to get it wrong is because you don't know what ET is. So this is equal to 1 over 1 plus theta ET. And PT minus PT given T minus 2 is going to be equal to R1 ET plus R2 ET minus 1. Because again, this is the actual price process. And when you're making your predictions 2 periods ago, You knew Vt minus 2, so you're not going to screw up because of that, but you didn't know the shock in period t minus 1, and you didn't know the shock in period t. So this is going to be equal to 1 over 1 plus theta Et plus rho minus gamma over 1 plus theta over 2 Et minus 1. Okay. And what we're really curious about in this model is what happens to output. Can we use monetary policy to stabilize output? Right? And if you go back to the very beginning of the model, which we can do, this is within our abilities. The very beginning of the model, we had equation 6 was yt minus y bar was equal to theta over 2 pt minus pt given t minus 1 plus theta over 2 pt minus pt given t minus 2. Right? We had people that were setting their contracts one period ago. We had half of the people were setting their contracts one period ago. And they're going to set their wages according to what they expect prices to be. They might make mistakes on the prices, though, and that will change their wages, which will change their real wages, which will affect output. Okay? And some people were setting their contracts 2 periods ago, so they were trying to predict today's prices given the information 2 periods ago, and they might have gotten that wrong because of news that came about between then and now, 2 periods worth of news, and that will affect their real wages, which will affect how many of them get hired. Right? So we can plug this in. Now that we have the price process, we can plug these things in, and we get yt minus y bar is equal to theta over 2 times this thing, which is 1 over 1 plus theta Et plus theta over 2 times this 2-period price prediction errors, which are 1 over 1 plus theta Et plus rho minus gamma over 1 plus theta over 2 Et minus 1. Right. Just taking this, maybe we can get this to turn into red, and this, and plugging them into 6 for this bit and this bit. Just plugging them in. And now we got some Et terms and we got some Et minus 1 terms. So let's put them together. Yt minus y bar, put all the Et terms together. We've got theta over 2 times 1 plus theta. We got theta over 2 times 1 plus theta. We get theta over 1 plus theta Et plus rho minus gamma over 1 plus theta over 2 Et minus 1. And that is how output behaves in this model. Okay. Yay, team, we've done it. Okay, and you're saying, what the heck, there's a lot of Greek letters up there. Does this mean anything, God? Probably not, probably not. It's going to be a long day. Right? You said that. I heard you saying that to yourself. I heard you. Nevertheless, it has meaning. It has meaning. If we take a look at this one, right? This is price prediction errors 1 period ago, right? So we have half of the people are making price prediction errors because they were trying to predict today's prices based on yesterday's information. And that screwed up their real wage, which affected output, right? And those guys, that's half the people, are going to make mistakes because of this shock that they didn't see when they were making their wages. Right? Fair enough. Okay? And the other half of the people are trying to predict things from 2 periods ago, so they're going to make mistakes for 2 reasons. They're going to make mistakes based on today's shock, just like these other guys, because they didn't know it either. Right? So that's half the people are going to make mistakes because of today's shock, that other half the people. And they're going to make mistakes because of yesterday's shock, because they were doing it 2 periods ago. They didn't know about T minus 1 either. Yeah? I couldn't hear you at all. So this, am I pointing at the right place, first of all? Yes, okay. Yeah, we should. We should multiply it by theta over 2. Absolutely, we should. Thank you. Thank you so much. Like so. Absolutely, absolutely true. Thanks. Yeah, people be looking like in 2 months from now, like, what the heck was going on there? But no, it's like that. It's like that. Absolutely right. So helpful. So helpful. Okay. So everybody will make price mistakes because of today's shock, which is why the half disappears, right? Because half the people do it from 1 period ago, half the people do it from 2 periods ago. They all make the same mistake because nobody knew that information at the time they were setting their wage. It was just unknown, and they did their best, right? But only this half of the people with contracts from 2 periods ago, only they are going to make mistakes based on ET minus 1 shocks, right? Because the guys that were making their contracts 1 period ago, they knew that shock already. So yeah, it was a shock, but now they know it, and when they're setting their wages, they can take that into account. So that doesn't affect their price prediction errors. They don't make mistakes based on that. Only the guys that were setting their wages 2 periods ago make mistakes based on that. Okay. So we get output can be affected by today's shocks, and it can be affected by yesterday's shocks because half the people didn't know them when they set their wages. Now let's talk about monetary policy. Remember, we had MT was equal to, I think, minus gamma ET minus 1. So this is monetary policy. That is, if yesterday's shock was really large, let's suppose gamma is a positive thing. It can be positive or negative. If yesterday's shock was very large, meaning that prices would naturally go up, right, from here, what we're going to do is we're going to reduce the money supply with the negative gamma. Okay. So, but we can have gamma be whatever we want, but that's our policy choice. Remember, we can't just say, well, things are bad today, I'm going to do whatever I want, right? Because people are going to be trying to predict this. And so we have to think about in what way is our behavior systematic. We don't have to ourselves think that we're behaving systematically, and we can do whatever we want each day, but people are going to treat us like we're behaving systematically, which means that from a modeling perspective, we have to know what that system is. Now, the current state of affairs in macroeconomics, in monetary policy, is for them to communicate the rule that they're working by as clearly as possible, okay? To the extent that they know it themselves. So that they say explicitly, if inflation goes up by 2%, we're going to increase the money or decrease the money supply by so much. They try to be as transparent as, maybe not as possible, but they try to be very transparent. It's the current trend. But even if we thought that they weren't being transparent, like even if they were just like going into a smoke-filled room and deciding based on who bribed them more or whatever they were doing, they're doing something. And people in this economy are going to be predicting what that something is. And in a rational expectations equilibrium, the prediction and the behavior have got to match up, right? Because if they didn't match up, eventually people would update how they're forming their expectations. So eventually they would. In real life, they don't have to match up every minute, of course, but in the long term, if the central bank is behaving in a particular systematic way, people are going to eventually learn what that systematic way is. So this gamma is important to us both because it's our policy, it's the system that we're using to set monetary policy, but also it's used because people are trying to predict that, and so they know that system too. And you say, what if the central bank is being totally random and just flipping a coin every day, whether they increase monetary policy or not? That too is a system, and we could have built that in as well, right? So even behaving just, They get up, they shoot a line of heroin, and I don't know. Do you shoot lines of heroin? I don't know. However you take your heroin, I don't want to get involved in your life. It sounds sordid. But however you do it, right? And then when they do whatever they do, that too is a system, right? Everything is a system, so we have to specify the system so that people can take expectations of it. Okay, and so this is saying that our monetary policy does not, there's nothing we can do about this shock with our monetary policy. Right? We can't smooth out this shock. So sometimes output is going to be high based on current shock. Sometimes it's going to be low. Sometimes we're going to have velocity is going to increase, output's going to be high. Sometimes velocity is going to decrease, output's going to be low. It's just going to happen, and there's nothing as monetary authorities that we can do about it. Okay? And the reason we can't do anything about it is that we don't have that information. Right? We don't know what that shock is. We don't have the ability to react so quickly to that shock by assumption. Right? In our first model we did, but we're only able to react to one period ago shock. It takes us some time to realize what the shock is. It takes us some time to actually change the monetary policy, to change the money supply and have that affect the economy. Okay? And that's, I think, reasonably reasonable that it takes time to do stuff. So, the stuff that we don't have time to react to, well, we can't react to, and there's no gamma there. There's nothing we can do about that. But this part we can do something about, right? We can actually, if we pick our gamma carefully, we could make this just go away, right? If we want, and it's totally up to us what our goal is, but if we want, we could pick gamma equal to rho, in which case this whole bit goes away. And time t minus 1 shocks don't even happen. And that's saying if output is, if velocity is high, let's decrease the money supply. Like if we have a shock, let's decrease the money supply in response to that shock so that it doesn't affect prices and doesn't affect output. You'll notice that would make it not affect prices either. Right? So we just completely clean out that shock. When we have a positive shock, decrease the money supply. We have a negative shock, increase the money supply, so that for that ET minus 1, we can stabilize output. Right? And this bit would go away. So in this model, we cannot solve all the problems. We can't get rid of business cycles. But if we're proactive, we can get rid of some parts of it. Right? If gamma was 0 and we were just doing nothing, right? We just had a rule where we leave the money supply the same all the time, then we would have output would be affected by today's shock, and it would also be affected by yesterday's shock, rho over what's it, right? But if we're careful in choosing our rho, we can use this rule and we can still smooth out this shock. Why are we able to smooth out this shock? Because we have better information than the people when they set their wages. They set their wages based on t minus 2 information, and then news came, and they couldn't do anything about it because they were locked into these short-term contracts. Right? They were locked into these contracts. The wages are wrong. What can they do? Well, we can change it so that the wages aren't so wrong. Right? At least that portion of it. Right? The prices look like they're going up. Let's change the money supply to bring those prices back down so that they aren't fooled, because we have better information than them, because we are working with t minus 1 information, whereas they were working with t minus 2 information. Okay? Now, is this realistic? Is this how the world works? You tell me. Nobody knows, right? This is kind of an empirical question. This is kind of how do you think the world works? You can look around. Different reasonable people can have different opinions. You can have yours. Even if your opinion is unreasonable, you can still have it. I can't stop you. But you give me my opinion on the exam, obviously, but it doesn't mean that your opinion changes. But sort of the thing to think about is how long do these contracts work? And we have it all done in terms of wage contracts, but we could just as easily have done it in terms of short-term steel contracts. It's contracts for anything that's an input in the production process. Yes, wages were the neatest, cleanest way to put it in here. But anything that's an input to production process, how long are these contracts, right? And then how quickly can central banks react? And if central banks can react to news more quickly than people can change their contracts, then the central bank can stabilize part of output. And if they are unable to react more quickly, then they can't so far. We're going to have more. There's going to be more. We're going to learn more. But given what we have so far in this model, that's what we've got. Okay? That your ability to influence output, given that we have rational expectations, is based on having better information or being able to react more quickly to changing information than the people who have the contracts. Okay? And that's why we have, in this model, that's why we have output fluctuations at all, is that they can't change their contract based on new news. But if we can change things based on new news, we can smooth that out. Okay? Questions about this? Yes? Yes.
Which is last year.
Yeah.
And how are we going to select for the past period?
Yeah. So did you hear? He's saying that this is the shock from a period ago, like I say a year ago, right? And how are we going to do something from the past? So maybe let me talk a little bit more about the math, and I'll come back. I'll come back to your question. But suppose gamma was 0, and we're not doing anything. Okay? Well, how much of this shock is around? Well, rho of it. And that's, remember, what that rho is how much of shocks persist. So when we had the shock in period t minus 1, rho of that shock is still around in velocity, right? Because these shocks are persistent. Now, if we had shocks that were not persistent, that is, the shock happened and then it's gone, which is kind of, I think, what you have in your mind as you're asking the question. That shocks happen in t minus 1, then they're gone, then we get shocks in at t, and then they're gone. There's no persistence. In that case, rho would be 0, that the shocks don't last at all. And so, absent central bank behavior, gamma equals 0, central banks doing nothing, what would happen is you'd have this shock, it would disrupt the economy, and then the next year, poof, it would be gone, and it would be a brand new world. And so all we would have here is ET, right? So all we would have is this bit. Even though we had 2-period contracts, because the shocks don't stay around, yesterday's shock would have screwed up yesterday, but it wouldn't have affected today at all, right? So that's a world with rho equal to 0. Let me actually write this. This is, I think, useful enough that people in their notes are going to want that. Then yt minus y bar is equal to what? Theta over 1 plus theta. Theta et. And in fact, pt is equal to, I believe, 1 over 1 plus theta. Yeah. So if there's no persistence in shocks, rho is 0, then prices just depend on the current shock, and output just depends on the current shock, even though we have these 2-period contracts. Okay? Because all that matters today is today's shock. Right? That's the only reason you could make a price prediction error. It's the only reason prices are affected. But what we actually have is rho. So if we did the same thing, if rho is greater than 0, but gamma equals 0, so we have no monetary policy, we get pt is equal to 1 over 1 plus theta et plus rho over, let me get this right, over and yt minus y bar is equal to I believe that's right. Yeah. Okay, so this is just the world where we have persistent shocks, but the central bank does nothing, right? And I think this is useful because it sort of shows you how to play around with the algebra once you've got it, right? So what do we have? Well, prices now depend on shocks we had, like what was the velocity 2 periods ago, because some of that's still around. And yesterday's shock is actually still around. How much of it's around? Rho of it's around, right? With some other stuff, but it's just equal to how persistent shocks are. And so if shocks are persistent, then yesterday's stuff is going to continue to affect today if we do nothing, right? We have no policy, right? And so likewise, output is the same. Because some of the people might have made mistakes based on yesterday's shock, because they were setting their wages 2 periods ago, output will be affected by yesterday's shock, right? Because that shock is still with us. That velocity was really high, some of that high velocity is still with us. Okay? And that's why when we change our monetary policy based on yesterday's shock, that we can affect output, because some of that shock is still with us. So I can say, okay, yesterday we had a shock, the velocity is high, it's still going to be high. Let me reduce money supply a little bit to counteract the effect of that, because the effect of that is still with us. Okay? That was actually useful. Yeah. Other questions? Did I answer your question, first of all? Yeah. Partly, yeah.
Expecting to see the monetary policy and the first term, which is represent the actual shock.
Yeah.
Because if we don't have any gamma and the first part, or this gamma minus gamma K minus 1,
Yeah.
which represents policy today, taken in consideration policy which was in the previous
Yeah.
shock. But we don't have any gamma in the first term. That means so we
Yeah. And
don't do anything about today's shock.
yeah. So the reason for that is because our money supply is always going to be reacting to yesterday's shock. So it's not that you don't see money in the first term, but it's always reacting to yesterday's shock. So it ends up lumped in the second term. But today's prices depend on this ET minus 1, this gamma term. Right? And that's because we are changing our money supply today based on yesterday's shock. So it looks like yesterday's shock, but this is not yesterday's money supply. This is today's money supply, which is a function of yesterday's shock. Okay? So we could, let me write this differently. And this would be a legitimate way to write this. I could write the whole thing as, let's see, do we have a place to write it? PT is equal to 1 over 1 plus theta epsilon t plus rho over theta, 1 plus theta over 2 theta over, no, I don't think there is that. Et minus 1 plus rho squared Vt minus 2 plus mt over 1 plus theta over 2. Right. All I'm doing here is in this equation, I know that mt is this, and that's where that gamma came from. right? So minus theta, ET minus 1, is the same thing as writing MT. And so this thing is the same thing, which I think is more what you had in mind. Today's prices depend on today's shock, yesterday's shock because of the persistence term, and the two periods ago shock because of the persistence term, rho squared, and whatever we set our money supply equal today. Right? But I've substituted that in because I can't just put in any money supply today because this is all based on people's expectations. Right? We've already solved out those price prediction errors. So we've built in that the money supply is minus gamma over MT. Like we can't write this equation without having solved it. And to solve it, we need to know what the rule is. Okay? And so it is this, but I can't just say, let me increase the money supply and prices will go up. Right? I have to be following that rule. If I want to follow a different rule, I would have to solve it again for that rule. Because whatever rule I have has a direct effect, which is kind of what we're seeing here, the direct effect of my money supply. But it also affects people's predictions of the prices when they're setting their wages. And we don't see that here. Right? And so we would need to take that into account. Right? The actual equation is the star, which has the price prediction errors in it. And so in order to solve that, we need to know what do people predict about how the central bank is going to behave. Right? And so this is true as far as it goes, but we have to bear in mind that we're not free to choose any m we want in this equation. In general, we are, but in this equation, we're not, because we've already assumed to get this equation that they're behaving in a particular way. Okay? If we want them to behave differently, we need to start from scratch and do it all again. Okay, that is the last of the material that can be on the exam. We will, of course, have class next time. In class next time, I will go over what happens if you guess wrong, because, of course, this is the guess and verify method. What you need to know for this is you need to know the assumptions that are going in, why we made them, and how to interpret the answers that you get. Okay? And you'll see a few questions like that. Also, for next time, like if you study over the weekend, well, for next time, if you study between now and then, or if you study over the weekend, in the 2 remaining classes, I will prioritize answering questions. So bring all your questions. I will answer questions first, do lectures second. Okay? Okay, see you on Friday.